Okay, number 8. As soon as this focuses. Here we go. A watermelon is dropped from the top of a 20-meter cliff. At the same time, a person at the bottom of the cliff shoots an arrow up towards the watermelon. The arrow strikes the watermelon after 0.3 of a second. Okay, so here's my cliff. Here's my watermelon. Here's my arrow. Same time as the watermelon is falling, is let go to fall down, the arrow is shot upward. Okay, what we know for the watermelon is that it's dropped, which means VI is 0. A is 9.81 meters per second squared down. What we know for the arrow is VI is something that we don't know. We know that A is 9.81 meters per second squared up. We know the height of the cliff is 20 meters. So whatever the delta D of the watermelon is, the delta D of the arrow will be 20 meters minus that. And it tells us it takes 0.3 seconds for the arrow to hit the watermelon, which means the arrow is moving at 0.3 seconds, or 4.3 seconds, and it means the watermelon is too. Okay, so this is the arrow. And the question wants to know, what is the VI? Well, for the arrow, there are two things we don't know, the delta D and the VI, so we can't find it right away. But for the watermelon, there's only one thing we don't know, the delta D of the watermelon. And we have the VI, the A, and the delta T of the watermelon. So delta D of the watermelon is equal to VI delta T plus 1/2 A delta T squared. The VI is 0, so this term disappears. So 1/2 9.81 meters per second squared, and delta T squared 0.3 seconds squared. So the delta D of the watermelon, 0.9 times 4.905, 0.44145 meters. The poor watermelon didn't get to even fall a half a meter before the arrow hit it. So what does that mean? That means that the delta D of the arrow is 20 meters minus 0.44145 meters. So the delta D of the arrow is going to be 19.55855 meters. Okay, and it is up. So now we have delta D of the arrow, we have the VI, we want the VI, we have the A, we have the delta T. So now we can do delta D of the arrow is equal to VI delta T, 1/2 A delta T squared, and we need to rearrange for the VI. So first step, move the 1/2 A delta T squared over by subtracting it, and then divide by the delta T. Okay, so VI equals delta D of the arrow, and it's going up, is 19.55855 meters minus 1/2. A is not going up, going down, negative 9.81 meters per second squared. Delta T is 0.3 of a second squared, and then all of that gets divided by 0.3 of a second. VI should end up equaling, I think on the top, you minus and a minus, you get a plus. And so it ends up being 20 over 0.3, or 66.6 repeating meters per second, works out to be positive, which means up. Okay, so that's it for number 8.